Greetings from Terry, here at D-Lab. Today's video subject, how to build a boutique amp from beginning to end. How to select your cabinet, lay out your chassis, circuitry, etc. I've had many requests for this video, so here we go. First step in building a boutique amp is what will it be housed in. Alright, so maybe you picked an old piece of test equipment, or in this case, maybe you have an old gorgeous 1940s RCA radio cabinet like this one. Alright, so here it is. She's a beauty. Now I've added a couple holes here, so my control lineup, I have an input jack, volume, treble, bass, and the power switch. Okay. Then I go inside and make sure to clear it out. Make sure there's nothing that's going to be an interference fit for the chassis. So in this case, I have this nice little Hammond chassis. It's going to go in there. This is a 10 by 6 by 2 chassis. They're like $10 to $12. It's not going to break the bank. So now I have my cabinet. I've got my chassis. What's the next step? Next step of your boutique amp build is pick your circuit. In this case, I'm going to build a Fender Princeton 6G2 basic 6V6 push-pull amp. As you know, the Princeton has a long history. It's a great amp. So what a perfect amp to build inside of that RCA radio cabinet, all right? And I just also happen to have the eyelet board. Yeah, I've already populated most of it, but this is that board that you see, and I buy these from Watts Tube Audio. So the next thing I do after I've chose my cabinet and my chassis size, and I have the circuit that I'm going to build, I actually build up a little kit. Alright, so I take these little wood boxes and I put everything in here I'm going to need. I got my power transformer, output transformer, filter cap, miscellaneous pots, tube sockets, and of course my eyelet board for the build. The next thing I do after I have my kit is I decide how I'm going to put all those components on this chassis. So here's the chassis layout. You can see I've already drilled all the holes. I didn't want to bore you guys with that, right? But let's discuss why I put the components where I did, okay? Because that's very important. So this area right here, that will be where the power transformer sits. He's going to sit right there, right? In front of him is the filter cap. Now this circuit, I elected not to use a rectifier tube. And the reason for that is this power transformer, this is your primary, here's your secondaries. There is only a secondary for the 6 volt and the high voltage. So there's not a 5 volt winding here for a rectifier tube, all right? So obviously I can't use a rectifier tube unless I go with a 6 volt tube, but I thought, you know what? If I'm having 6V6s like are in the Princeton, I really don't have to worry about a rectifier tube. So I'm going to just go with diodes on this build. So here's our setup. This is my power supply area. These will be for the 6V6 output tubes. My output transformer is going to sit here. And it's a classic tone, right? This will be my preamp tube, the 12AX7. This is my inverter. Now the reason for this type layout, I want my power supply as far away from that input tube as possible. Okay, so let's flip him around. So this here will be where my input jack is, which is in line with the preamp tube. So if you envision my eyelet board sitting in here, okay, he actually will sit like this, right? So this is the input side, which lines up with the 12AX7. So my input jacks, tone circuits, all that fire towards the front. So that's why I go volume, treble, bass. I always put the treble right after volume because I want to keep those leads as short as possible, because the treble control has a higher chance of noise than the bass. Alright, so that's why I lay them out that way. Now let's go around to the back. These are my speaker jacks. I always try to line up my speaker jack leads to go right between the output tubes and hit that output transformer. you never want your speaker leads to go over here towards the preamp, because you'll start getting feedback and nasty noise and you'll be very upset. Okay, now the primary of the output transformer goes through this hole, and you can also see I use these rubber grommets. Okay, some guys don't do that. Some guys just make bigger holes so that the wires don't hit the chassis, but for a couple pennies you can put in these nice little grommets, so I always use those. Okay, now you can see these little brass screws, right? So let's go underneath. What are those for? They're for the standoffs, and these standoffs are for the eyelet board. So he is going to mount right around there. Okay, now I'm going to get this up where you can see it. So you're probably wondering, why is that eyelet board closer to the front than it is to the rear? Well, the reason is I need to be able to wire these tube sockets. And then the front of the amp is simply going to have the pots, which sit very close to the front panel. So I don't need a lot of room in the front of the chassis versus the rear. So that's why I always offset the eyelet board. Another thing I want to point out about the chassis build is when you buy these pots, you see this little tab? Well, that's a locator tab. So if you drill the hole for the pot and the locator tab like that, you don't need to install a lock washer on the back of the pot. The locator tab will keep that guy in place. Another good investment if you're going to do chassis work, you see these nice holes. You may wonder, how does D-Lab do that? Does he have some gigantic drills? No. You find one of these old vintage chassis punch sets, you drill a locator hole, pop them guys in, and that's what you get. Chassis layout's done, so the first thing you need to do is get your tube sockets installed, and of course your power transformer. Then we'll get the filaments wired up, and I always do that first because that wiring is going to sit next to the chassis and it's going to be underneath everything. I want the filaments tucked down, out of the way, and keep that noise level down. So here we go. It's time to install the sockets and get her wired up. Main chassis items are installed. Got our power transformer, output transformer, filter cap, 2 octals for the 6V6s, inverter tube socket, and the preamp socket. Now if you look at these octals, you'll see I aim these keyways to the right. That's because the filaments come in on 2 and 7, so I'm going to hit those in parallel. And then these guys, you can see that the openings, pins 1 and 9, are faced that way. It's because I want the filaments to come in on the back sides of those also, keeping those filament lines away from the signals. Filament wiring is complete to the tubes, and you can see my little 100 ohm resistors there for hum balance. Go down there, hit the preamp tubes. So next step, let's get the speaker jacks installed, and let's get the high voltage leads hooked up to the output tube sockets. So the chassis is coming along well. You can see the layout's looking really nice. I've got my controls installed, but there's one thing I need to do before I install the eyelet board and start wiring. And what that is, you see these shafts? You see how long they are? Well, they need to be cut to fit into the new cabinet. Alright, so this is in here like so. Alright, turn this guy around. You can see the shaft sticking out, right? So they're obviously way too long. So they're going to need to be cut. But the other thing that I want to do, I've got these 3 cool knobs, old Bakelite knobs that used to be on this radio. I want to put them back on. So to do that, these shafts will have to have this D cut out. So I'm going to have to cut them, get it on the milling machine, cut some flats so these knobs go back on. Then I can continue with the wiring. Alright, I've showed this in a previous video. So what I do is I got this cool little vise here that I made back in high school. Got the pot clamped in there. I've cut this shaft off with a Dremel tool to the approximate length. And I put a pencil mark right there, and that's where this shaft protrudes from the cabinet. So now we need to mill in a flat and check this thing and make sure it fits right. Alright, so there it is. The initial flat's been cut on the shaft. Don't know if it's deep enough yet, so I'll do a little test fit, and if not, we'll take a little more off. So here's the first D shaft cut, and this is the volume pot. So there's my little Nobaramus. Let's see how she fits. Nice and snug. It's going to do the job. So you can see right there I got about, maybe a 1/4 inch of flat showing. So when I install these knobs, that'll allow me to trim the shaft so these seat properly against that front panel. Alright, so I got the D shafts cut in all 3 pots. Volume, my bass and treble pots. So the next step, I'll clean these up a little bit. Take a file and deburr them and get them mounted in the chassis, and we'll start wiring them up. So where are we at with the build? Well, we've got those controls installed. Input jack, power switch, and then I got this nifty light platform. It's got 2 GE47 bulbs. Okay, so the reason I use 2 is because when this guy goes in here, I want it to light up those slats that you see and the old original tuning dial. So obviously that's a job of 2 lamps. Next thing we're going to do is start wiring up the eyelet board. If I can get this thing to where it sits where you can see it. Here we go. So it's in there. You can see I color coded the wires. So I use the orange for the high voltage, and then the blue will go to the cathodes. This white here is the signal line that's going to go to the inverter. Yellow coming off here, that's for treble. Got a ground lug there for the controls to bond to, and there's another one over here for the power cord when it comes in. Filter caps awaiting this high voltage lead here. So all in all, it's going to be a pretty quick process at this point. Sheet's complete. We're ready for test. I've got a pair of Sylvania 6v6s installed, a Sylvania inverter tube, and a Sovtech 12AX7. And of course there's my light platform. Now you may be wondering, why did I use plastic to mount those lights? Well, here's why. The base of these lights is not isolated. There's only one wire that goes into these little lamps. So the bases would actually be connected to ground had I used a piece of aluminum, which would have shorted out my filament lines. You know, you've got that little balancing circuit, so you got like 3.3 volts or so on each side of your filament. Well, if this gets connected to ground, guess what happens to your balance circuit? So that's why you have to use the insulator when you mount these type of lamps. Wiring underneath is complete. Got our tone controls all wired up. Here's my bias resistors. I used a cathode resistor type bias to the output tubes. This does not have negative bias. So this is 500 ohms that I used with a 100 microfarad cap in parallel. Tube sockets all wired up. Now if you look here, you'll see my inverter tube is a 7-pin tube. I do that because I did not have the tremolo circuit, so I did not need a full 12AX7. 6AV6 does a great job. I used it in many of my amps. This thing's ready to go. Before you power up your amp project, you're going to want to take an ohm meter, put it on a low ohm scale, say 0 to 2K. Alright? Put your negative lead to the chassis. And first, take your leads, make sure that you got a good chassis connection, because we're going to do some quick checks. Number one, you want to make sure that none of your power supply leads are shorted to ground, because that'd be very bad, wouldn't it, if you turned on your amp. So here's your filter cap. You can go right to this filter cap and make sure it's open. You can go up here where it feeds the screens. It's open. Over here, this feeds the preamp section. Nice and open. That's all good, right? Next thing you want to do, Let's come over here to your preamp section, and you've got your cathode caps that go to the 12AX7. So when I go there, I should see continuity, right? Because you want that grounded. And you want this one grounded, which it is. That will ensure that when you fire up the amp, there's no shorts and you're going to have current flowing through your tubes. Here's that bias resistor I was telling you about. On this side, it's 0. On this side, got about 500 ohms. That's what I'd expect. So at this point, I'd say we're safe to fire it up. Note on the tone controls, this amp has treble and bass, whereas the Princeton 6G2 board did not support that. It only had a tone control. So I added some tone caps here and the pots like you would see on a Fender Deluxe circuit. Initial power up, I've got my meter over here set at 1500 volts DC, and I'm monitoring the plate voltage going to the output tubes. I have a dummy load hooked up to the 8 ohm output jack, and my scope is connected to that. Okay? And as an input, I've got an audio generator set at about 2 kilohertz at 150 millivolts, simulating the guitar input to the amp. Controls are volume, treble, bass. So let's kick her on. There you go. Look at there. There's our high voltage shot right up there. That's because of those diodes, right? You'd expect that to be pretty quick. There's my lights. Tubes are warming up. No smoke. Let's bring up the volume and watch our scope. Here we go. Go to the scope. There she is. Nice breakup. I'm going to crank it. And if you listen carefully to the dummy load, you can actually hear it. Okay? Now, let's bring up the treble. So I'm going to bring the treble back, volume up. Now here's the treble. Nice square wave. This thing has perfect gain. I bet you she's going to sound like $1,000,000 when we put it on a speaker. You can see my plate voltage dropped down to about 380 because now the output tubes are loading that power supply. So how do you mount your new Hammond chassis in that old radio cabinet? What I like to do is maintain the old original holes that mounted the old chassis, right? And how I do that is I add these wood blocks to the side of the aluminum chassis. There's a couple mounting holes there. Screws go through into the chassis with a bead of glue. So then you just take your chassis, slide him in, and the old original screws come up from the bottom, and it's in there just like the radio chassis was back in the day. Get everything to line up. So there we go. I need to find my knobs. Here's the old Canabaramases. So as I said before, input, volume, treble, bass. Okay. So these were the original knobs that were on this thing in its past life. Of course, I milled those shafts, right? So it'll fit. Looks pretty darn good. There's the old power switch. He's set in a little bit because there's about a 1/2 inch distance from the front to the chassis, but it operates great, plenty of clearance. Okay. Next, let's power it up to see how cool it looks with the lights off. So I've killed the main shop lights. I've got a little incandescent bulb over here to my right. What I want to see is how nicely the dial illuminates with those two GE47s. Okay. So kick them on, get this light out of the way. You can see that the dial lights up nicely. There's the tubes inside, very cool. Slide him over here. And the other thing that's going to be really neat is the light comes out of the old speaker vents. So it should shine down like when you're walking through the aisles of a movie theater, right? They got those vented lights so you can walk safely. So that's very cool. So how does a Boutique amp sound on a guitar? Well, here you go. lots of chime. D-Lab saying mission accomplished to the step-by-step boutique amp build in this vintage RCA radio cabinet. After watching this video, if you take these basic techniques and apply them towards your project, you'll be successful. Just make sure to use something like the Fender Princeton circuit, which I used here. Yes, I did modify it slightly. I put in diode rectification, bass and treble controls, and did not use the tremolo control. But what's really nice about Fender amps, if you build them right, man, are they super clean and chimey. Now this one's on right now, okay? Do you hear any AC hum? No. Remember, there's no choke in this thing, and it's still dead quiet. Now here it is full blast. I've got this Utah speaker over here, a little bit of white noise, but once again, there's no nasty hum or squeals. It's a great circuit. So if you take your time, you can end up with something like this and have something that you'd be proud of to have in your recording studio. Now this video is about the build. Later on, I'll have a demo shot of this amp being played, but for now, this is just to get you going on your project. So I hope you enjoyed the video, and there'll be more to come from D-Lab.